Today we're going to talk about the MKS Monster 8 with the TMC 2208 version 2 and how to install it. So there's a couple things I want to go over on the board. I'm going to go over them kind of quick, but as you can see, there's going to be several different names for these as we go along. So I'll review that in just a second, but normally it's X, Y, Z, and then it may or may not be Z2 or your first extruder. Then it'll be your second extruder, your third extruder, your fourth extruder, and your fifth extruder, depending upon your configuration in the Marlin firmware. This is normally designed for something like a Voron, but in this case, I'm just going to talk about how to install the actual stepper. Now note, I am using, in most cases on my printer, the actual cooling fins on top of this, as well as a cooling fan. But for the purposes of this tutorial, I'm going to leave off the actual cooling fins so you can see the stepper, and I'm only going to be working with it for a moment. But we need to actually figure out now how to configure this. So what I'm going to do is I'm actually going to go over to my desktop and show you the actual manual. So over here, as you can see, we have the MKS Monster 8. And this will actually give you information on your board. For instance, if we go to the hardware and then we go to the actual pinouts for, we'll say, version 3, you can click on this file and it'll show you the pinouts. And as you can see, it says driver 0, driver 1, driver 2-1, driver 2-2. Then it says driver 3, driver 4, and so on and so forth. But they're associating these with your axes. So you can see that there's X, Y, then there's Z1, Z2, and then there's E0 all the way up to E4. Now this may be confusing, but I'll explain what's occurring in the Marlin firmware so that you have a better understanding of what is occurring. They normally design this, I believe, for a Voron board. So I'm going to actually call out the configuration, and I'll explain in future tutorials how to deal with these situations where it may be a dual Z set of steppers. So let's go over here for a second. You can see the board again. They show it slightly different. This is actually, in my estimation, not correct based on what I've seen in the pins file, but I'll show you that in just a second. I want to show you the actual physical configuration. So they have a note here that says something about how to set your jumpers for the actual power. We're going to leave it on the default for now, but make note of this manual. I'll leave a link in the description so you can actually read it for yourself. And I'll actually show you how to set it up. Now there is one other thing that I want to point out. And as you can see, there's a jumper down here that's for USB power and power. When you're running a TMC type stepper, you want to make sure that you're on direct power for the jumper, which I'll review in a moment. But that means you're running off the power supply. I'll actually show you an error that will occur a little bit later in the tutorial, and how you can handle that and what causes it. So let's scroll down and find our actual stepper, which is the TMC 2208. And as you can see, as we scroll down, we're finding the category that we're actually going to be working with. So in here, you can see that this is actually our jumper configuration right here. And that's under the TMC 2208. It also is for the other TMC type steppers, according to what they're saying here for UART mode. There are different types of modes that I may not cover, but I just want to make you aware of this. So we're going to go back over to the board now. And I need to point out some things on the actual stepper real quick. So as you can see, it says that it's a TMC 2208 version 2. The enable pin is actually written on the Sulk screen right here. And I also need to point out that on the Sulk screen you can see green and black. That's important so that you can connect the x-axis. So what we're going to do is we're going to zoom out real quick here. And we're going to set the jumper. Now I'm using a red jumper so you can see what I'm actually doing. And I'm going to put that on the second jumper pins in the green section. There are a set of pins just below it, but we're not using those. So we're going to take the stepper and we're going to insert it inside of here. Now normally, like I said before, you'll use the actual heat fins to cool it on top, but currently I'm not going to be using this during the tutorial. There is a little sticker on the bottom that'll help you install it. I'm also not going to show you in this particular tutorial how to do the cooling for automatic cooling of the actual steppers. I will try and show you that in the TMC 2209 video. So if you like and subscribe, you'll be able to know when I do that. So now that we have that configured, I need to take out an SD card and actually insert it in here. So I'm going to push in, pull this out, and I'm going to insert it into my SD card reader like so. Then I'll put this in my computer, and you may hear a beep in a moment. And we'll go back over to the computer for a second, and we'll set this up. So I'm actually using the current version of Marlin that exists today, which is 2.0.9.3. These are subject to change. So it may not be valid in another month or year. I just want to make you aware of that, but the process probably will be the same. If not, I may re-record the tutorial. So let's go over to VS Code. I'm going to actually click on the Explorer, then Open Folder. Then I'm going to click on my Downloads folder where I've downloaded Marlin 2.0 version X, which is the one that we're currently working with that I showed you a moment ago. We're going to have to go into that folder, then into the second one because this has been extracted, and then select folder. Once we're inside of here, what we're going to have to do is figure out what our board is. So we're going to click on the Marlin folder, the source folder, the core folder, and then boards.h. Inside here, we're going to search on Monster 8, and we'll find our board. So we'll click on this, we'll copy the entire thing, we'll close out of boards.h, but before we do that, we want to make sure what we know is our actual chipset. So as you can see right here, our MCU in this case is the STM32F407. And where I'm getting that from, besides the pins file, is actually on the workbench over here for the computer. The MCU is actually the center processor here. Sometimes people will call it a CPU. So that's what I'm actually talking about in this situation. And the actual writing for STM32 will be there. So I'm going to minimize the core and source. I'm then going to go to configuration.h and I'm going to search on motherboard. I'm going to find where it says the ramps board and I'm going to paste what we just copied. Then I'm going to change the serial port to -1. And to set up the actual build environment, you're actually going to have to do that in platformio.ini. Currently it's set for the Mega 2560, but we have a different one. So that thing I pointed out about the actual chipset is in this INI folder, and we're going to find the STM32F4. Inside here, we're going to search on Monster 8. And as you can see, here's our default environment. So we're going to copy this. Then we're going to close out of this file. And we're going to go to our platformio.ini and paste it right here. Next, we're going to set up the actual stepper in configuration.h. So I'm going to search on A 4988. Inside here, we're on the X stepper, so we're going to be using the TMC 2208. So we're going to copy this, then we're going to paste it right here, and that's how we set up the stepper. So we do have to do further configuration depending upon what resolution you want. Here are the default values for X, Y, Z, and then whatever other extruders or robotic steppers you may work with. A hint or a pro tip, these currently are very difficult to configure and it may not work as of yet. So we're going to scroll over to the configuration advanced.h. Inside here, what we're going to search on is 800, and this is just a quick way to get to where I want to go. So as you can see, we have the X stepper set up. Now, root mean square may be of importance depending upon the steppers that you're using, so please consult your data sheets for both the TMC 2208 and the data sheet for your NEMA 17 stepper. It may vary from what I'm doing, but it's a root mean square computation, so we're going to leave this alone for this tutorial. So when I was talking about resolution a second ago, you see how it says 16 here? That's 1/16 of a step. So this has the possibility to go to 256th of a step. I don't suggest it, but I'll show you the process on how to set up a normal step. So as you saw over here, it was 80. So if we go over here and we want to increase it from 80 to say 32, because we're doubling the value, it's now 1/32nd of a step. So we need to change this value for 80 to 160. If we were to increase it further to 1/64th of a step, we change this to 64, and then we would change this 160 to 320. And that goes all the way up to 256, that process. So now I want to show you debugging. So if you search on TMC _debug, what you'll see is we need to enable the debug. So I'm going to hit the shift / to remove the comment so we can do TMC debugging. Then I'm going to go back up to the other one, which is right here for driver monitoring or monitor driver status, and do the same. So when you're in an actual configuration, you may not need to use these, but I thought I'd point them out. The other thing I want to show you is that there's going to be some important things about hybrid stepping. I'm not going to actually show you this in the tutorial because I want you to set up the default configuration so that you understand how to do it. But if you remove the comment for this, you'd be able to use it. It is more noisy than normal. And then we have, obviously, let's see what we got here. We have Stealth Chop enabled by default. But if you read these comments, you can actually modify some of these so that they'll actually work in spread cycle when disabled, meaning commented out. So there's another thing about power supply when you're using the chopper configuration for spread cycle. And what it says is what power supply you're actually using. So if you were to set this to 24, like we're using for our current power supply, which is 24 volts, you could set this up easier. So now that we've got this configured, we're going to actually have to build it. So as you saw a moment ago, I talked about the Mega 2560. It was built by default when they made the build. So to clean this out, we'll click the clean button, and that will clean out the actual build for us. Next, what we'll need to do is actually do the build. Now I clicked on the checkbox to do this, and this may take a moment to build. It may fail on the initial try, like it just did. So we'll hit the checkbox again and we'll let that build. If it fails a second time, we'll go back and find the very first thing that failed and correct it. Sometimes what happens is it builds something out of order, and so that's built before I actually have a chance to use it in my build, or not built, and that's why you see that failure. It has to do with the way they set up the actual platform IO file to grab things possibly, but it's not a big deal if you hit the build button a second time to take care of it. Now if you watch over here, you can see that the actual build is taking place for our board, and you can see that it's almost done. So in a second, it's going to produce this file right here, which is our firmware.bin file renamed. So we're going to review this in File Explorer. So I just brought it up, and as you can see over here, the previous load loaded successfully. So if we go back, we can load this one that we just built in here. So if you look over here now, if you wanted to reload this build and this one didn't exist, you would rename this one to what it looks like in lowercase with the .bin. Then you'd be able to reload it on multiple systems. So now that this is complete, we're going to go back over to the workbench. And on the workbench, we're going to pop out the drive. We're then going to place it in here. And before I place it in here, I want to show you something. This currently is on USB power. So if I plug this in, you may hear a ding. So I'm going to remove that for a moment. As you can see, I've already installed the actual cord for the NEMA motor over here. So I'm going to plug this in. Then I'm going to plug this in, and this could take upwards of 30 to 40 seconds to actually load. So wait for the ding that shows that it is actually connected to your computer in a moment. So this might take a bit. While this is going on, I'm going to show you that we're actually going to use the power over here to actually connect our 24 volt power supply. But you heard the ding just now. So I'm going to unplug this. I'm actually going to move this over to direct power. And then I'm going to go back over to my computer to double check the actual power over here. So if we go to the desktop for a second, you can see that we have the website for the actual Monster 8, and it shows what the power is. So the top one here is actually the heat bed. Then we have the power supply. Now we need to know what's positive and negative. So I've marked the screws on this as red for power or voltage, and then the one unmarked is actually ground. But we can confirm that it's either DC 12 or 24 volts based on the pinout diagram, as well as inside the actual manual they'll explain this. So let's go back over to the desktop and get that set up. So on the desktop, I'm going to take out the actual cord. I'm going to plug in the ground first in this case. There's no power going to the power supply right now. So I'm going to tighten that down. And I'm going to tighten down the actual voltage connection. And for safety, I'm going to lock this down so that we don't have an issue. So next I'm actually going to energize the system. And that means that I'm not going to be able to touch the board for safety, because I don't want to damage either yourself or the hardware on the board. So now I'm going to plug it in. And as you can see, it's now energized and connecting to the system. But I want to show you this error that I talked about previously. So I'm going to unplug this for a second. I'm going to put the power cord over here and let it discharge. Wait until all the lights go out for safety. Then I'm going to pull this, and I'm going to show you what occurs for an error. So if we're on USB power and I plug this in, we can now connect to this using Pronterface. So I'm going to show you how that looks. So over here, I'm in Pronterface. Now I currently don't know what the COM port is. So the way to find that is to go over to the desktop for a moment. and I'm going to search on Device Manager. So once Device Manager comes up, I'm going to then go over here and it says COM port 8. So I'm going to close out of here. I'm going to go back over to the view so you can see what's going on. I'm going to check over here to see if it's there, which it is in this case, and I'm going to click connect. If it weren't there, you can highlight this and actually put in the number for your COM port. So it says the printer is now online. So the debugs that we just turned on, we can actually check it by doing M122 to check the status. Now this will fail. So as you can see right here, it says bad response, and then it says all low. That's because there's no power. So we're gonna go back over to the board for a second, and we're gonna actually repair that problem. So on the board, I'm going to unplug it for a second. I'm going to move the jumper back over to direct power. I'm then going to plug it back in. And I'm going to then energize the system with the power supply power. So now we'll go back over to Pronterface. And inside Pronterface, we're going to do a disconnect and a connect. You can see the printer is now online. So we'll do the M122 again. So as you can see down here now, it's okay. So to test this, what we can do is we can move it 10 millimeters, noting that there is no end stop. So I'm just showing you in between this. If you were to test it with an end stop, you have to double click to get it to stop. So I'm going to show you this real quick in 10 millimeters. So you see how it moves? And then if we want to move it back. So at this point, I want to thank you for taking the time to watch my tutorial. Please remember to like, subscribe, and share. And for my patrons and the people that support me on PayPal, I'm going to post a thank you scroll at the very end of the tutorial. So everyone take care, be safe, wear a mask if needed, and get vaccinated.